mutable arrays in Haskell. Okay, in previous video we talked about immutable arrays, how to work with them. This is some examples, and today we're talking about mutable arrays, how Haskell deals with mutable arrays. Haskell has a special kind of type class which called IOArray, mutable array. This is a multi-parameter type class, and it has 3 parameters. A first parameter is an array, the data type which represents array. The second is element type, and the last is a monad type. You can say, what is a monad type? Why it is here? Okay, it is here because Haskell is pure language, and we're talking about mutation, and mutation is some kind of side effect which actually happens inside of the memory of this array is represented. So that's why we need this monad here. Of course, if you look at array type A, it has a kind from star to star to star. This means that if you want to build this type, you need to provide the index type. This must be a member of the X type class. We talked about this type class in the previous video about immutable arrays. And we need to provide the element type. After this, we can build this type of array. Also, you can see that an array class is parameterized over both A and E. So the instances can be specialized to certain elements types. So in the same way as it was in an immutable array. And also we can specialize the type of monad. Inside this is the context inside which the mutable array will be manipulated. So it can be a IO monad or a ST monad. As you can see here, we have some instances, and this is instances provided for IO monad and ST monad, and for different types of the elements where is the specialized instances. Also, it's some functions, get bounds, get so we can get the boundaries of the array, get number of elements. We can write to this array and read from this array. Okay. And we have these functions to build array, new array underscore. So this is exactly the same functions as we work with, we play with this function. The previous video about immutable array, but here we have this context, the monadic context, because we do the mutation. And we have this function for reading and writing to arrays, mapping arrays, and mapping the indices. Also, we can deconstruct the mutable arrays. This means that we can get the bounds of the array, get the elements of the array, and get associated pairs of the array. And we can do the conversions between the mutable and immutable arrays. We can freeze. This means that we take some mutable array and convert it to immutable array. And we can do otherwise. We can take the immutable array and convert it into the mutable array. Okay, now let's provide some examples. How can we work with our arrays? At first, let's import our module. Import Data.Array.Mutable array. This module contains type class, which contains all the functions needed for manipulations with arrays. Okay, let's define main function. So, as I said, we do all the manipulations inside the monad. This means that we can use the notation here. And let's start with creating an array. So where exists a function new array which creates array. You can see it's type signature. It's take bounds, it's take some element which we want to fill this array, new array, and it's return to us a new array A, and you can see this array inside the M monad because we can do some side effects when we manipulated this array. Okay, let's say I want create a new array from 0 to 3. I want 4 elements, and I want to fill this element with some char, for example, A. So we inside this type is monad, so we need to extract the value, and the value will be array. And let's just print it. Print this array. Oh, we can see some errors, and let's try to load this file. And see what's happened. So I think we need to specify the types here. So here we need to provide the type, let it be IO, and inside this IO we need to provide the array type, and this is the IO array, which has the as indices int, and as values it has char. Okay. We have still error here. No instance for show in array. Okay, the problem that is there is no show instance. But we can to show the data of this array, we can try to use getAsOx function for this array and extract the pairs, the list of pairs, and try to print them like this. Let's check and run main. And as you can see, we have this array which filled with our A. So this thing works as expected. The next thing we can try is let's try to modify array. So let's write to some index, for example. We have a write array function which need our array at first. Then we need to provide the index, for example, 2, if I want to provide the last element. No, 3 for last element, and I want to write x into the last element, last position of this array. Now let's check this. As you can see, we have x here, not ax. We do the modifications. Also, I can, the same way, I can very easily read array at any index, for example at any tree, index 3, I can read this element and print this element. Yes, we can see we have this X here. In the similar way, we can work with the STArray. So let's import stmonad for this. So this is a control monad st. And let's define some function. I will call this function work st. Inside this function, they will do the write our logic in which we work in this STArray. We can work with this STArray in the same way. We can create it, but we will need to modify types a little bit. We have stmonad now. Stmonad needs some s context of the thread, state thread, and also we need to provide a new type STArray for this array, and it's also need this s here, s thread here. Okay, I think after this we can do exactly the same thing that they do in the IO. Okay, I think they need to import this name. So we need import Data.Array st. Okay, I can't print here because they have we don't have this IO monad now. We're not in the IO context. So let's remove this from here. This printing. We just will create this array. And just modify it like this. And after this, let's get a socks and return this socks. So we can remove this return because get a socks provide for us exactly the monad of list of the associated pairs. Now I can use run st to extract this value. So let's rename this to the work IO and define our main as run st work st, and they need to print the result of this. Let's try. Yes, you can see that they have this array where they modified the last element at x, and they do this inside the stmonad here. Okay, they review the IOArray, STArray, where is also interesting array, storable array, which allow to this is a special type of array mutable IOArray which stores content in a contiguous memory block within the C heap. And you can extract the pointer to this memory block and work with this array with foreign language like C. Okay. So I think this is the main information which we need to know to start working with the mutable arrays. I think in the next video I will talk about vectors which provide some more useful interface like a lists to work with arrays. Okay, but on today we will end. Thank you for watching. Push like, push subscribe, write comments, and see you later in the next video. Bye bye. Oh, let's put these two actions together. They have ST work, and they have also work IO, and let's compose them. Like this. And let's run this, and you can see the result of these two actions.